You're live. Woo!
Are we rolling already? Look at this.
I'm a streamer now, Mike. That's what's up.
Are you streaming? Are we streaming and recording?
Streaming with like real software.
Move that way. You're not on camera. Move.
I'm like right in front of it.
I know, but you're not showing up.
Oh no! Dude. It's like this is a different thing. It's like on a delay or something. Let's watch this one. Okay.
Now you're
live.
That's
good.
good.
Okay.
Let's talk to the world.
Hey, what's up, everybody? If I didn't say hi to you yet, hi. My name's Will. I'm one of the core organizers here. Thank you for coming. First off, I want to thank our sponsors, Virtuel, for the space. They've been running with it for 5 years, so that's really good. And to Song Consulting. Joe, would you like to say anything?
We're just Song.
Okay. Are you hiring? Are you looking for work? Are you just happy to feed us?
We're just happy to feed you right now. But we're a custom software development company. We work in Angular on the front end and open source stuff on the back end. We're always looking for work, always looking for people, right?
Give an example of a
Song, SOG,
Oh.
to sing a song.
Give an example of what type of project or something that
Sure, so we're one of the most fun things is we work with manufacturing Bloomington, who makes the basketball training machine. They machine throws the ball on the court. How you program the machine, create a workout, or a program of workouts, and how you do your stats is through the software we create.
Sweet. Cool. Well, yeah, check them out at SongMN.
Where are you located?
Minneapolis,
Cool.
St. Anthony, Minneapolis.
Got it.
So thank them very much for the pizza and beer.
Thank you.
Anyone else looking for work or hiring or have cool announcements of stuff, Angular or web related, coming up? We just had Midwest JS, so that's not a thing anymore. Until next year. Yes.
I actually do work for a pretty firm, but I just switched my 12 years out of alcohol into that, so I'm really good at it.
Awesome.
To be honest with you, this is something I have to talk about. JS people and full stack are very hard to find. You're not even kidding.
And what was your name?
Mike.
Mike.
Sorry about that.
No sweat. So, thank you, Mike. Anyone else? Yes.
My name is Jeremy. I actually just recently graduated this past May from Oxford College, and right now I'm looking for my first software dev job. If anyone knows anyone, let me know. I know Python, HTML, CSS, JavaScript. I'm really into accessibility. Right now I'm trying to teach myself React.
Awesome. Cool. Thanks, Jeremy. Anyone else? I'm building a DDR fab. That's the thing I'm doing. That's totally unrelated to this. Cool. All right. Well, then, without further ado, I'll turn it over to Mark to tell us all about VSCode and running debuggers for containers. Do we have Wi-Fi? Yes, we do. The Wi-Fi is Meetup, and the password is very, very secure. It's lowercase guest 123.
Well, hello everyone, welcome, and thanks for coming to the talk today. We're going to be going over a new set of tools that Microsoft recently released for Visual Studio Code called the Remote Development Extensions. And specifically, we're going to be looking at the Remote Container plugin. But before we get there, we're going to do a little bit of a dive into Docker, because Docker is one of those things that, as I was saying to someone earlier, it seems like someone either knows everything about it or know nothing about it, and so I'm trying to get a level playing ground here so that everyone can make it through this talk. Now, my name is Mark Dobossy, for those of you who I haven't met yet. I've got a pretty deep programming background, not well, there has been quite a bit in web development, but a lot before that. I spent about 14 years in academia doing high-performance computing, big engineering simulations, that kind of stuff. Then I had a 5-year stint in the finance industry where I was looking at developing web-based portfolio optimization and modeling tools, including doing some machine learning algorithms and things like that. We used a Python backend with probably Shutter here, a vanilla jQuery front end. Unfortunately, Angular did not exist when we started that project. It existed by the end of it, but didn't help us at that point. Now I run my own consultancy. I focus primarily on mobile native applications using Ionic and traditional web applications using Angular, and a lot of the stuff I do has pretty deep database backends, which these days I'm doing a lot in Python for those backends. Now, why this particular topic today? I'm going to start by telling you guys a little bit of a story this was about 16, 17 years ago. As a graduate student, I was working on a pretty big project where we were working on the university's new giant high-performance computing cluster. Back in the day, we called them Beowulf clusters. That's kind of what got Google its start. Essentially, the idea was to throw a whole bunch of hardware at a problem and see what comes out the other end. The issue was, when you get bugs in these systems, they were pretty hard to determine where the bug was coming, how to fix it. We had a particular issue where we throw this simulation, and it was like a 1,000-node cluster. And if we were using more than about 200 or 300 nodes, we'd get this funny error that would happen. It would start propagating through other nodes, doing calculations, and then the whole thing would blow up. And try debugging that. Someone tells you use a smaller set. So we go down to maybe 16 nodes, and the problem didn't exist. So we had to use these very large sets. Spent about 3 months trying to figure out what the heck is going on with this. And finally, I threw up my hands, and I went down to the supercomputing center, and I sat down with some of the people there. And one guy basically said, "Have you heard of TotalView?" I was like, "Well, no, what's TotalView?" It turns out TotalView is a dream of a debugger for high-performance computing that lets you literally view the whole system down to individual bits moving through individual processors and anything in between. You can mark things off, and I mean, it's an incredible piece of software. We fired the thing up, and within a half hour, we figured out what was going on, and within a couple of days, we fixed the problem. So there was 3 months of lost work because of tooling issues. And we're in a sort of similar paradigm shift these days, where over the last 10 years, we've seen this move from kind of bare metal or virtualized servers to sort of a more containerized environment. And there's a lot of benefits that containers give to developers, which we're going to go over later. You get benefits for developers, for ops people, kind of down the line. But the tooling has lagged quite a bit in that regard. It's been difficult to find tools that allow you to debug in containers, to develop with containers, to kind of hodgepodge pieces together, but it wasn't all that straightforward. In recent years, Microsoft, who I basically spent my whole adult life giving grief to, came out with Visual Studio Code, which I think probably everyone here has at least used it or uses it every day. I feel like it's a fantastic piece of software, and I think Microsoft has really hit the ball out of the park on this one because they listen to the community and they bring in new tools and changes that help us as these technologies change. And these remote development plugins are no exception. And going forward, I really feel that these plugins are going to help to really streamline what we do. When I was looking for pictures of motivation, I came up with a picture of Terry Crews playing a flute, which I thought was a pretty inspirational photo, so I figured I had to put it on this page. So now this evening, we're going to start off with kind of a 30,000-foot overview of what Docker is and how it works. We're going to put together a Docker container for those who haven't had a lot of access to Docker. We're going to move on to how we look at workflows in a Dockerized environment, because this is really where you need to join Docker to Visual Studio Code. If you're just doing Docker for the sake of Docker, these Visual Studio Code plugins might not help you too much, but if you're thinking about your workflow in terms of Docker, they can be very beneficial. Once we get up, next we'll end up diving into the meat of this talk, which is going to be what Visual Studio Code's remote container plugin is, how it works, and how we get up and running. Finally, I'll wrap things up with fun stuff. We're going to do some demos. Along this talk, I'll be splitting my time between slides. We're going to spend about half the talk on Docker and about half the talk on Visual Studio Code. And there will be about half the time that's spent on actual live demos. And we all know that live demos can either go fantastically or they can explode horribly. So hopefully, if it's the latter, at least it's entertaining. So I want to get a feel for the room in terms of Docker exposure. So I'm going to throw up here, I've trademarked my 4 levels of Docker knowledge. The first level is the landlubber. Anyone in this room who wonders why there's a whale with some boxes on its back on this slide, you are a landlubber. Someone who's really had no exposure to Docker at all, maybe you've heard of it, but you've never used it. Is there anyone in the room, and it's absolutely okay, that sort of falls into that category, a real level, low level? A couple people. Great. Next up is that whale watcher on vacation from Chicago. You know, you're on the boat, beautiful whale, oh look, there's another one. So maybe your DevOps guy shoved all your code in a Docker container, and it works really well, and it's like this black box of magic, but you don't want to touch it, because you don't know what it's going to do. Anyone sort of at that level? Okay, so we've got a few people kind of at that level. Next, we've got the Captain Ahabs of the room. These are people who have a complicated relationship with Docker. You use it every day, you know how it works, you do some cool stuff with it, but you have some issues with Docker, and it seems like Docker has a few issues with you. That's about where I'd say my level with Docker is, and probably the majority of kind of the dev people do sort of have that relationship with Docker. And finally, we've got Jonah, who knows Docker from the inside out, okay? You're the person who does Docker this, Docker that, and whoever your deity is, they've instructed you to go out and praise Docker to the world and get everyone using it. So if any of you are in this room and you really, really know Docker, I've heard they're hiring, and it turns out that there's very, very few people that really do know Docker from the inside out. So we've got a good mix of people in here. For the people in the room with little exposure to Docker, I hope that the next few minutes here can give you a little bit of insight and can give you some information to help follow along with the talk. For the people here who have a lot of experience with Docker, maybe you'll glean a couple nuggets out of it, but I just hope I don't bore you with tears. So now I promise this is the only slide I'm going to literally read because I couldn't memorize this quote. Docker is a set of platform as a service products that use OS level virtualization to deliver software packages called containers. Containers are isolated from one another and bundle their own software, libraries, and configuration files. They can communicate with each other through well-defined channels. And of course, we know this is a quote by Albert Einstein, which over here on the left, or perhaps it was from Wikipedia, which I get too confused these days with the amount of knowledge that's espoused. The key for those who are new to Docker is that it gives you a distributable and consistent environment in which you can develop and deploy your applications. So let's go over a little bit of terminology. So I'm going to be talking about a lot of these things, and this is actually something that even a lot of people who know Docker really well get a lot of these terms mixed up. The first is a Docker file. So a Docker file is a file with a set of instructions that tell a container how to build itself and then what to do with itself after it's built. Think of it kind of like a recipe card with ingredients and instructions. Next, we have an image. Now, an image is kind of like a Lego, how your kids' Lego basket. It's modular and reusable, and it's the components that we define in our Docker file that make up our container. So an example of an image is you might go grab a Nginx image if you need a web server, or you might go grab a Python image if you need to run a Python image. These can be thought of as sort of the ingredients in your recipe. Next, we have our container, which is our self-contained sandbox that's actually running either our code or whatever applications we put in it, and they result from executing our Docker file. So when Docker follows all of the instructions in the Docker file and assembles the right images and commands, we get a container. When you go to a website that's running in Docker, you're talking to a container. So it's the actual instance of whatever environment you're using. Next, we've got Docker Hub, which is a repository of images. You can kind of think of this as the NPM of Docker. There are hundreds of thousands of images available over at Docker Hub. Many of them are first-party images straight from Docker themselves. Many of them are called partner images, I believe is the term they use, which are people like NPM and Python, where the software groups get together and sort of release an official image. And then there's a whole lot of third-party images, some of which are amazing, some of which you don't want to touch with a 10-foot pole. So you need to be a little bit careful when you dive into the depths of Docker Hub. There are tools out there, if you Google, that will run your various security checks on whatever software is running in these images before you run them, so you know if there's any outstanding issues that maybe a later version would fix. I tend to run my images through these from time to time, so a lot of times things get out of date. And if you don't stay on top of it, it's just like running a server, you can end up with some security holes. And finally, we've got a tool called Docker Compose. Docker Compose comes with Docker. I believe on the Mac and on Windows it installs Rail inside it. On Linux, I think you have to install it separately. But it essentially manages the life cycle of multiple containers. So imagine a situation where we're putting together an API and it needs a database. You might have a container around your API and a container around your database, and you would use a Docker Compose file to ensure that these guys spin up and wind down with each other and can communicate with each other. So some people may have heard of things like Kubernetes and Docker Swarm and these other kind of big tools. I kind of think of Docker Compose as sort of a small version of this for mere mortals like myself. You know, it's for small and even medium-sized projects where you don't need to be scaling out across thousands of containers. Okay, so now that we've gone through this terminology, let's have a demo. What we're going to end up doing is constructing a very simple Docker file. And because I always like to tell a story behind what I'm doing, that is what we'll do. So I've got my awesome website here on my desktop, and we are about to launch this very complicated set of HTML documents, and it's going to be launched in an Nginx container. And we're not sure if Nginx can handle such a complicated set of files. So I want to run it locally and make sure before I send this guy off to production that it actually works. Apparently I just went too dark.
Oh yeah.
Let's see. So what we're going to do is we're going to take my awesome website directory here. We're going to open it in Visual Code. And this has nothing to do with the Visual Code tools we're going to talk about later. Using this as an editor. I'm going to make a new file and let me know if this is too small for you guys to see. So I'm going to make a new Docker file. And in that Docker file, I'm going to write 2 lines of code. I'm going to do from Nginx inline Alpine, and then we're going to do copy /index .html to /user Nginx HTML. Okay, so what are we doing here? First, the from line is the image that we're going to use. So the thing before the colon, Nginx, defines the image that we want to have Docker go out to Docker Hub, grab, and pull down. And in this case, Nginx is the official Nginx image. After the colon, you can specify a version. This comes in really handy if you're trying to test something in, say, Python 2.63 and see why it's blowing up, or if you want to see if your app builds properly in, Node 8 or something like that. So we're saying we want the main line, which is going to be our latest version of Nginx, and Alpine is the distribution system or the packaging system that it uses. You'll see a lot of Alpine because it's very slim. It's a Linux system that's very slim. You also see Debian a lot because it's very flexible. So most of the time when you see just a default, if I just wrote just Nginx, it would grab the mainline Debian version of this image. In this case, I'm grabbing Alpine because it's smaller and quicker to download. So we're going to save this file. And now here at the command line, make sure I'm in the right directory, which I am. I'm going to type a couple commands. First command is docker build -t my awesome Nginx dot. So what this is saying is use Docker to build an image. So we're actually now building our own image. It's not a container yet, it's an image. We're going to give it a tag of myAwesomeEngineX, so we can refer to that later when we actually develop our container and deploy that. And then dot just says use the files in the current directory. So it's going to use the Docker compose file, or sorry, the Docker file that we just read. So when we click this, you'll see some code goes up. In this case, it goes up very fast because it's using cache here. All this stuff is cached on this machine by intent, so you guys don't have to wait for downloading it like that. And now that we've built that image, when we Docker run, we want to give a name to the container that we're going to run. So we name it awesome engineers container. And then we are going to map a couple ports, because now we're going to have this web server running inside our Docker container, and we need our outside machine to be able to see it, otherwise we can't access it. So we are going to map port 80 from the host machine to 80 in the container. And we are going to use that myAwesomeEngineX image that we just built. You notice, it seemed like I typed that pretty quick. Docker is amazing in its command line recognition. You can tab for days. Okay, so take the first couple letters, click tab, it knows what it is you named and what you built. It makes life a whole lot easier. So now we click this, and nothing seems to happen. So believe it or not, this container is now running. Because of how I set it up, there's no log output or anything like that. And we are just going to go to localhost at port 80, and we have, I don't know if you guys can see that, but hello world, Angular, and then I'm running in a Docker container. So now we've got a Docker container running on this machine, which prior had no web server whatsoever installed on it. I think there's a patch or something there, but we'll pretend there's no web server. It's running in Nginx in that container. So, I'm going to go back to this. So obviously this was a pretty trivial setup, and you might be looking at this going, what's the point? I mean, yeah, I can see it was an easy way to essentially install Nginx, which I didn't have to do, because Nginx installed the container, and you didn't have to do much config, which if you're doing this for real, you would have to do a lot of config. So what's the clear benefit of using it? And what you'll find is that when we start to talk about workflows is where the benefits become much more clear for using a Docker container versus just installing things on the machine haphazardly. So then you might ask, where in a software lifecycle, in the software lifecycle stages, do we benefit from using Docker? And the too long didn't read is yes. Okay, so you're going to find benefits just about everywhere in your software development by containerizing. To go into a little bit more detail, if we think about sort of the development and prototyping phase, having a repeatable, distributable development environment is absolutely fantastic. Everyone is on the same page, everyone talks in the same version numbers, and especially when that environment can map directly to your production environment. You know, there's a huge advantage there. When you move to production, you've essentially been working in the exact same environment, which alleviates a lot of issues you have in that transfer to production. How about for deployment and things like that? Well, having a repeatable, distributable production environment is awesome for your ops people who are going to be deploying your app. Or in my case, as a team of one, that's me as well. And it's especially awesome when that production environment matches the environment the developers are working in. It causes a lot fewer issues. In addition, on deployment, we have everything wrapped, so we're not dependent on things that are installed in server, which we're going to talk about in a little bit. How about for things like testing and QA? Well, having a repeatable, distributable testing environment, blah, blah, blah. It's kind of the same benefit. Having that stable environment across the board, in my mind, is one of the hugest perks of Docker, and there's a whole lot of other benefits that come along with it, which you will see in a bit. So let's talk about a little bit of a more real-world scenario. So here we've got a fairly simple web app. Okay? Has anyone seen a setup like this before in their careers? Sure, you've got a REST API, you've got your web app, which is your piled Angular, the cross-piled Angular stuff just being statically served. You've got a database server that feeds the REST API, and it all goes through some reverse proxy that filters your stuff down to the right place. And just for the fun of it, we add some certificate management because the new hotness is let's encrypt, so let's encrypt. Now, in a scenario like this, where does the code usually live? I've seen systems where there's a back-end repo and a front-end repo, and maybe there's a configuration repo, and then there's a certificate secrets repo. The number of repos in systems like this seem to spiral out of control because everything is sort of thought of as a separate piece. And the thing about these, imagine when you get that new developer who comes in to your company, right? And you're the one in charge of getting him up and running, and he's going to be a front-end developer, but he needs a copy of the API on his machine. He needs that running to be able to properly do the development. Well, now he's running Windows 10.12732, and everyone else is running some other version of Windows, and you can't quite get the right version of Python working, or you can't quite get this working. But it can be a real nightmare for getting new developers set up. On the flip side of that, has anyone here ever gotten that call in the middle of the night that your app just went down, and it turns out that Ted, the IT guy, decided to update the kernel, and when he did that, he updated everything, and suddenly versions are out of whack, and the whole thing came crashing down? I've been woken up by that call. It sucks. It absolutely sucks. So the way that these things work is they work until they don't, like this poor guy here. So now let's take some steps to start improving this system. There's a really easy step we can take right off the bat, and that's literally just Dockerize all the things. Now, I wouldn't recommend, especially if you're using that term when you go into a meeting, Dockerize everything. But the idea of putting these systems inside of containers and isolating starts to give you benefit immediately. So for example, now when Ted, the IT guy, goes and updates the kernel and updates a whole bunch of other software on the system, as long as he didn't screw up something specifically with Docker, you're probably going to be okay. And now when you get that new guy that comes in, you have him go to a couple repos, he can check out that REST API, and he can fire up the database and the REST server just with a couple command line tools, and now he's up and running. Right? So just wrapping these things in containers can really help that workflow as you go forward. Again, the code in this case, this typically wouldn't be something that would change how your repos are laid out. Now I know everyone doesn't do a repo this way, but there's a lot of systems that are set up like this. And so now, we're feeling a little bit better, right? We're able to lift that weight a little bit more, we're a little bit more comfortable. So now let's go to the next step. And this is going to be the one that may be a little bit contentious. Just about everyone I talk to about monorepos has an opinion about it, and it's usually always different than mine and different than everyone else's. I don't know how that works. I actually don't even really like the term monorepo. So when I think of a monorepo, I think of like Google's monorepo, which is something like 7 terabytes. It's this huge, huge monorepo of every single line of code Google's ever written. And unless you're some IT guru, good luck with even trying to figure out how to use that. I'm thinking more, I guess I'd more coin this maybe like a microservice repo, where we're essentially taking all of our services that are related to our product and putting those in a single repo. So it's not your whole company, it's just this particular project. So this gives you kind of one repo to rule them all. You get the benefit of your API and your app now can share versioning. You don't have those issues where your app's talking to an API that someone changed, those sorts of things. We can do tests across this easier when everything's in one repo. So there's a lot of benefits to putting the project in a single repo. And you don't absolutely have to do this, but this leads to the next step after we watch this guy who is really pumped up about getting everything in his non-repo. Now when we go on to the next step, we're at a level that I call almost Zen. This is when we bring Docker Compose in. So now we've got everything in our monorepo, and we write some Docker Compose files. In those Docker Compose files, we can say, this is our production setup. We need our reverse proxy and our certificate management, and we need to run the production versions of these servers, and yada, yada, yada. Then you can write another Docker Compose file right next to it that's specific for your developers. And in this case, we are exposing everything on localhost, so we don't have to worry about URLs and certificates and all that jazz. We have our REST API, we have our database server, and maybe we include a nice little web database management tool like PHP Writer or whatever the Postgres one is called. Notice here, though, that our web app is kind of sitting out in la la. And there's a reason for this at this stage, and this is why we're at almost Sept. Typically, the way that these distributions work in terms of container with your web apps is you'll do a layered container, where the first layer of the container ingests all your code, uses something like Node.js and all the tools that it needs to download to compile your code. Then it spits that code out into the next layer, which would be, say, Nginx web server, which then does the serving. Then you take all that Node.js stuff and you just throw it away, because Node.js can make a Docker container huge. When I was putting together some of the Docker containers for this, I was getting up well over a gigabyte per container when I would start installing Node.js. So it can take up a whole lot of things. So a lot of times we don't want to deal with that, so we do this sort of multi-layer approach. There's a little bit more than the scope of this talk. So we wouldn't want to use that kind of container for our development, because we essentially don't have any development. But let's take a look at, we'll just send this off. You know, this is sort of the level of Zen that we're trying to achieve here. It's pretty amazing. I don't know how guys do it. That is pretty cool. Okay. So what we're going to do now is we are going to look at a project that looks suspiciously a lot like what I was putting up on board. So what I've done is we've mono-repoed or microservice repoed the whole thing. We've got a series of directories at the root level. We've got a database directory that contains some scripts for starting it up. We've got an Nginx directory which contains some configuration and some files that need to get passed around for all that Let's Encrypt stuff. We've got our API in a directory here. We've got our client, and we've got a deploy directory. So the deploy directory is what we're going to use to either deploy to our server or to deploy to our local machine to start doing the whole thing. Let's just take a look at what this kind of looks like. So we'll start with the complicated one. A Docker Compose file basically has you list your services, and you can issue commands that essentially override the commands that are in your actual Docker file. So it lets you do this kind of mixing and matching. You can do things. She recognized me all the way over here. So in this case, we're firing up an Nginx proxy. We define the image we're going to grab here, the ports that we're going to open. We fire up our little Let's Encrypt deal. We have our snippets database, which is just a Postgres database. So who has ever tried to install Postgres on a local machine? Would you enjoy it? It can be a bit of a nightmare. Well, here you can do it in like 4 lines of a Docker file and boom, you're off. Then we have our snippets API, which is an API that runs in the back end. You'll notice here that we have this little production environment file here. That's going to look something like this guy, where we store all of our dirty secrets. Okay? Now, I wouldn't recommend doing it this way in actual production. These get passed through as environment variables, and anyone who's done this sort of stuff realizes that environment variables are very leaky. There's all sorts of systems out there that you can use for doing secrets within containers. This is just sort of a naive approach that I'm using for this particular problem. Then we have our client software, and notice the API in the client, the build is referring to the directory that they live in. So if we go look at our client, we'll notice that there's a Docker file here right alongside the client code. And in that Docker file, we do that layering deal that I was talking about. So we grab a node image, we install some stuff, we build the production version of our code, then we move on to an Nginx image, copy stuff into it, copy from our build layer to that same directory we did last time, and then we fire up the server. Okay, so this is how you kind of do that layered approach in a couple minutes. Okay, so now we've got all of this deployment stuff here. How would it work? Okay, if we were doing this on a production server, it would be a matter of going to the server, and if all goes right, you set these files up correctly, you can plop those files in a directory, and you can literally do Docker compose up. And it's going to take over and do everything else for you. Then when you need to update things, you do Docker compose down, adjust things in your files, Docker compose up again, or more realistically, you pull it from the repo when the release comes out, you Docker compose up again, and you're off. For a developer, we would do the following. So let's see, I'm in the client directory. I'm going to do this in a terminal. Visual Studio Code has this issue when you run Docker compose natively that it doesn't like to quit properly. So we're just going to run this from this directory. So we're going to cd into snippets to deploy, list the files in there. So we see we have this Docker compose dev YAML file. And we're going to say Docker compose up, maybe F, Docker compose dev.yaml up. So what this is saying is run Docker compose. The default file is the production one, which is just Docker compose.yaml. So we have to do an F flag and tell it another file that we want to do. And up just says spin up everything in that file. So when I hit this, we're going to see that it's recreating my containers. And now we're getting logging stuff out here. I have my Django API running, and you see we've got our database running. If we append a D to this, it will daemonize the whole thing, so we'll go in the background. For now, I want to be able to start and stop this thing at will. So now that our backend is up, if I open a new tab, close our user website here, and I go to localhost 8000, you can see that Django REST framework was nice enough to give us a little browsable system where we can go start logging in. And we can see, this is our snippets program, so we can see all of the data that's in here. This is also serving your typical JSON data, so if we click here, we can see what the response back would be if we were to query this and say, and do an application. So now we've got our API and database running in a Docker container, and we can go over to Visual Studio Code, cd into snippets client, which is where all of our Angular code lives, and just do the traditional ng serve. So this is going to build things out. We all know that this can take a minute or so. Are there any questions at this point? Thanks. Any issues? This will go pretty quick. Has anyone noticed that Angular 7 and 8 seem to build lots? For me, my build time seems to have gone up. This is not how that's good. Okay, everything is compiled. And so if I go back here, and I throw up a new tab and go to localhost 4200, you will see we have our snippets client. Shrink this down. Is that too small for you to see? Okay. So this is just a little app. This is actually an app that I use for when I'm just playing around with stuff. It lets me just paste in snippets of code and categorize it by tags and things like that. The new things like I've been working with there's an auto entry library to kind of rebug people for VRX, and it's awesome by the way. I've been playing with that in the context of this. You go ahead and click the O.Y tag and get all of the really bad code. By the way, if anyone can tell me what this JavaScript script function does, by the end you can talk to me, you get a free subscribe year from me. So that's essentially what this little app does. Okay, so But going back to this, you'll notice that now we're living in this sort of limbo world. Some of our stuff in a container. In that container, we don't have Visual Studio Code talking to it at all, and then we have our front-end code running directly in Visual Studio Code, which may not be the optimal way to do things. Back to So you may be asking the question, how can I develop and debug my code when it's running in a container? And again, that's part of why we kept our angular code out. If we want to debug it, we might have some issues. And the answer is, if all you want to do is edit your code, it's actually really easy. In fact, the way these containers were set up, the code lives on the host system, and we bound those volumes to our container. So we can edit them directly in the host system. The container sees it, updates it, and everything. But once you want to start doing things like, I'm running Django here, so I want to inject a particular Python interpreter into the equation. Or maybe I want to run Visual Studio's debugging code, debuggers. That becomes an issue because we can't cross that division. But so it used to be really hard, and that's what Visual Studio Code has changed. So what are these VSC remote development extensions? I think it's good to understand a little bit of how they work. It's actually pretty brilliant. So when you fire up a copy of Visual Studio Code, you've got your UI layer that sits on top of the Visual Studio Code engine. What these remote extensions have done have allowed you to move that engine to another place. Okay, so we can plop that engine in some other OS, in some container somewhere. There's a lot of ways that you can do this. Then your actual client, the Visual Studio Code, just becomes the UI layer, right? And everything is actually running in the remote OS. So here, we've got this injected, what they call a VSCode server. It handles your workspace and extensions. Okay, so most of the extensions on the little extension marketplace will work inside of these remote containers. We've also got access to the source code, the terminal, the running app, and the debugger, all within either that container or that remote OS, depending on how you So it's this really cool separation of tasks, and it essentially, for lack of a better term, makes Visual Studio Code, at least the piece that you're using, like a thin client that just shows you stuff and takes input, which is kind of neat. And because all this stuff is local, it acts like it's in there. It's not some jerry-rigged SSH tunnel that's fragile and have issues with getting this stuff working. It's actually all local to the engine that's doing this. It's pretty cool technology. And here, I refer to this as a remote extension. I think there should actually be a remote plugin. The reason I do that is because there's actually 3 different plugins they've developed so far. You've got remote Windows subsystem Linux, I think is what they call it. I don't run Windows, so I'm not too familiar with it. But I guess it's that little Linux system you can install on your Windows machine. Ubuntu or something. The base of it. One of the issues with WSL is, up until now, you couldn't easily access the files on WSL from within Windows. It's sort of a separate system. The second thing we can do are remote containers, which is obviously what we're talking about tonight. And the third is remote SSH. So remote SSH lets you remotely SSH into some server on the other side of the world and do this sort of stuff. There's sort of a fourth option that I've seen instructions on how to do, and I was actually going to try to do it for this talk, but it didn't quite come together. I think it's still a little bit fragile, which is being able to do a remote container over an SSH client. So you'd be able to install a container on a server on the other side of the world and remotely work with it using Visual Studio, which would be pretty awesome. When I do a lot of my mobile development, one of the issues I have is when I'm trying to test things on a phone, I need an accessible address from my development API. And that makes it extremely difficult to debug things when I'm trying to use the phone and my development API is on some other machine that's not my laptop or whatever I'm working on. So that fourth option is something I'm kind of waiting with bated breath to get to it. Okay. So now let's go ahead and have a little bit of fun. Let's play. Excuse me. Let's start playing with these tools. After I grab it. Okay. So we'll go back to our project that we've got running here. And the first thing we want to do is actually get our Angular app running inside the document, which is not something a lot of people try to do. It turns out it's pretty darn cool. So the first thing we want to end up doing is going to the extensions tab here and making sure that we have the remote. Oh, I must not have Wi-Fi. Oh, that's okay. If you search for the remote extensions, I think I've got them. Hope I've got them installed locally. You can see here we've got remote containers, remote SSH. There's this remote development, which is the one that you want to install and kind of brings everything in. So that's our first task. We've got to get that installed. The second thing we need to do is we need to get our snippets client directory in its own workspace. This is an actual question. Does anyone know how to do this from Visual Studio Code? Like move a folder into a new workspace? I would think you'd be able to do something like right-click on it and open new workspace with this folder, but I've not been able to figure out how to do it. But it's time I said yes, we else doesn't. Oh yeah, you can definitely open it from the terminal. That's. Oh yeah, maybe I can do it internally. Let's try that. Oh yeah, that worked perfect. Thank you. Okay, so now we've got our snippets client open in its own workspace. Here we have this Docker file that we're not going to use, and so in this case, and the reason why I started with this one, we're just going to let Visual Studio Code build a Docker file for us, and it does a pretty good job at this. We'll have to tweak it a little bit to get it to do some things we want it to do, but it'll actually set everything up for us with a couple button presses. So what I'm going to do here is I'm going to click on the little green down in the corner here. It's a little hard to see. You get this little green remote development icon. When you click on it, you get your options, and the one we want is to add development container configuration files. So this is going to be your first step. And this is going to think for a second, and then it's going to give us a couple options. The first is we can use that existing Docker file, which, as I said, we don't want to do. The other option is there's a whole bunch of predefined configuration definitions that Microsoft has put out. I think there's like 80 or something like that. And there happens to be one that we will use. If you start typing node here, we're just going to grab the latest LTS, which is node 10, 20, 13, or 16 or something like that, as well as TypeScript. So we click on this guy, and it made a new .dev container directory at the root of our workspace. So it's sitting right here in with all of our snippet, this is the snippet client code. So now, first thing we're going to look at is this devcontainer.json file. We want to name it something other than this, and this naming is particularly important because if I spell it wrong, it's going to have to rebuild the whole thing instead of using the cache version I have here. So be careful about this. It is going to be the client container. Okay, and that's going to show up down in this little green bar down in the bottom. It's going to expand out and show us which container we're running with this one. We'll take There we go.
I had the remote ready. I just looked at it and it's like, oh, it's 7:51, I better be ready.
The next thing we're going to do is open up a port. So the port we're going to open up here is 4200. And then
This is not a
this is not a Docker file. This is what Visual Studio Code uses to launch your document.
this is configuration for the plugin.
For the plugin, exactly. So you have to configure that, and you have to configure that. And then we have the extensions that we want to install. This is tiny, don't worry about it. I'm just going to do copy and paste. So these are the extensions that I like to use when I'm doing Angular development. And so now we have this configuration file set up. The next step is to look at the Docker file. So again, we're installing the same node LTS. In this case, it's the Debian version, so it's doing some Debian stuff, it's doing some user stuff. I'm not going to worry about that. This section here, it's trying to update Yarn, which for some reason takes forever. So we're just going to mute that and not worry about it. And then for our npm install, we want to install Angular CL. So we're going to save all this. And now, when we click on this little icon here, we get an option to reopen this workspace in a container. Fingers crossed, this will work properly. I don't think it should need any network access because it should all be fast.
So what it's doing is creating the image.
Exactly.
Setting up the container.
Yep. And then it's injecting that server into the container and installing all the extensions that were specified. So it's already done. It's up and running. So when I open a new terminal here, you'll see that my path is different. Now it's workspace with snippets and client. Now I'm living inside this container in Visual Studio. And what we can now do, I'm just going to change this and say do some snippets from Docker. Save this guy, and then we're going to fire up ngserve. In this case, I have to specify 0.0.0.0. Doing localhost or 127, they don't work inside of a Docker container without a whole bunch of configuration stuff. I've got a close friend of mine that does a lot of Docker stuff. He says, don't worry about it. It's a dangerous thing to do when you're running on bare metal, but when it's contained to a Docker container, you don't have to really worry about exposing these sort of universal escape ports. So we're going to fire this guy up. And apparently a new version of Angular CLI has been out in the last 3 hours since I updated this. Yeah, I know, it's crazy. So now this is going to run. Any questions up to this point now? Well, while we let this one. So we're going to end up building this code out. And we get this warning saying you're going to blow the world up if you use the wrong host. I guarantee you won't, at least not in this case. And so now we're going to go through, so build in a minute or so here.
So this is using the CLI to post the application inside the container, right?
Correct. Correct. I'm using the CLI to run.
Unix or anything.
Nope. I'm using the regular Angular development server because now I want to use this in the context of a developer's machine. So it seems to do it so much faster than Okay. So now, if I go back to here and I reload my snippets client, we see hello from Docker. Congratulations, we're running from inside of Docker. Great. So the next step that we want to do now is we want to pull that API from its Docker container and bring that into Visual Studio. Because this is when, in my opinion, the real cool stuff. So I'm just going to minimize this window down. I'm going to go to Snippets API. Open this guy from here, once again. And we're kind of going to do the same process here. We're going to click our little green button. We're going to add a development container configuration. And in this case, we're given a few other options, because there just so happens to be a Docker Compose file. This is a legacy Docker Compose file from way back when I spinning these things up on my own. It's just lucky that we've got it here because it gives the option to sort of make a template for us. So I'm going to use that file, but then we're going to switch it to another file. Then it's going to ask us for which service. We're not actually going to use any of this. We're going to change that in the configuration file here. No, we don't open it yet. We'll put that fast. Again, we need to change the name. So this one is going to be the API container. Our Docker Compose file. Now, we're accessing this Docker Compose file that's right here. We actually want to pull out the one that's in that deployment directory. So we're going to change this to snippets deploy, and then we want the .dev.yaml. Then it's going to load a local Docker Compose file here that's right alongside our dev container. We'll go into that in a minute. When you stack two Docker Compose files like this, you can overwrite variables or overwrite services and things like that. So that's what we're doing here. We're going to inject some of this VSCode stuff that we need before we go into it. The service we're going to use is going to be snippets API, and our workspace folder is going to be workspaces/snippets API. So what we're going to do is we're actually going to mount a parent directory to this guy. The reason we're doing that is because all of our Git information is in that parent directory, and that gives us access to the new polls and all sorts of stuff like that. So we're going to mount files in as the parent directory, and then we're going to tell Visual Studio Code that this subdirectory is where we actually want our workspace. Next up, we're able to say some services we want to run. And this is why this guy got complicated. Remember, we got to fire up that database server alongside of our API. So here, we're going to fire up snippets DB, as well as snippets API. And then in our extensions, we are simply going to install the Microsoft Python extensions. If anyone here does Python, they're really good. Any Python extensions are good.
Anything you do debugging capabilities for Python?
Yep, absolutely. Okay, so now we want to look at this Docker Compose file. There's only a couple lines we've got to change in here. Instead of Postgres, this is going to be snippets API. That's the service we're going right now. Our volumes is going to be /workspaces. And I believe that is all we have to change. And then it's overriding the command to sleep infinity. So basically that container will stay open. When your main command dies, your container shuts down. We don't have that happen. Okay. Now this is the one that's given you trouble in the past. So again, we'll cross our fingers. We open this down in the container. Details here, so we can all lock it good. I had it already ready. At least that's easy to do. And then I think we're installing the Visual Code server, which means we didn't have to install everything in the container, which is great. And we are up and running. So now we have our Python code base running also in the container within Visual Studio Code. Now, one thing that can get a little bit confusing here is when both of our windows look the same. Okay, that can drive you a little bit bad. So one thing I like to do, well, first what we're going to do is open up a Python file. You'll see down here in the bottom, all of those as it's supposed to. It's supposed to start loading. I don't think it's fully loaded yet. It should show that it's loading up the Python tool set here. Unless I misspelled. Just make sure here that I didn't misspell. That's right. Oh, but basically now we can go back to our local host 8000. using Python that lives inside of our container, and we're spinning up our server. And here we've got our API working. I'm a little concerned that we're not seeing. I'm actually going to just try here. We're going to back out of this container. So one option we have is you can reopen the container locally, which backs you out of the container. That's everything now. And then it will tell you want to reopen it. We'll give that a try. It worked. And we're just about done here. It's, for some reason, it doesn't appear to be. Let's just see. Yeah, it might be. What's the is guest
Meetup.
okay.
Prompts you for password. It's lowercase GUEST 11123.
Okay, I see that we're running into a little bit of an issue here. What I was going to show you is that when this gets working, which it is working at home, you're able to fire up the Python debugger on I'm just going to do one last try. Back into this guy and really want to get this to see. There we go, now it's saved. So maybe that was the issue. Why, but sorry about this, guys. This is what the screen is. Still, usually you start seeing Python installing without it installing another debugger. Essentially, what you're able to do is launch VSCode's Python debugger on your API at the same time that you're launching the Chrome DevTools debugger on your front end. And you've got basically a debugging machine. I mean, it's just awesome. You can watch traffic go from your client app to your server, watch it step through how things are handled. And it really does make that sort of server client debugging, it takes you to a place that is really, really difficult to do in the past. And obviously it's somewhat difficult now because it's not working, but I promise you it worked extremely well up until right now. So to close up here, just a few final thoughts. Docker containers really do bring a lot of value to the entire development cycle. They make development, deployment, and maintenance and testing all more streamlined. We run into a lot fewer issues with compatibility and things like that. And while our dev tools for a long time have lagged, they're starting to catch up now. And I think that VSC's remote dev tools do a great job of bringing containers together with the development environment. And with just a few change lines in your Docker file config, you too can be running your VSC inside containers. And you didn't see it here, but debugging different services using multiple languages spread across multiple containers is really, really a cool way to start looking at your apps and debugging. And so with Visual Studio Code, these developer tools, YouTube can be the developer equivalent of our friend Terry Crews running. Are there any questions? Yes.
So this is running all the containers locally on your local.
Correct.
Right?
Correct.
So we have developers in our organization who remotely mount a drive
Yep.
on a system that will files and then use VSC for the network traffic. It
Yep.
seems like you could do that in container somewhere close to the virtual.
Yeah, so
that they're running.
right now, the way we set things up here, your container does need to be running on the same machine. However, they do have instructions on how to do this SSH tunneling thing, and I think they're working on a tool to kind of automatically set it up for you, where you can plug into a remote container that's living on a server.
Using your whole development environment set up.
Exactly.
To connect to it.
Exactly.
Whatever.
Exactly, and that's what I think is coming, and with the speed that they've been releasing changes to these tools were released in May, I believe, or at least announced in May, maybe released in early June, and they've come a long ways even since then. There's been a lot of additions that really listen to the community for bringing things in, and they, like I said, they do have instructions on how to do that. I was going to try to show that in this talk. It's just not as user-friendly as the rest of it.
So then, like, I'm using VSC, I use the project manager. It seems like if you're running in containers, you have to spin it up.
Yeah, well, you would.
Into it, right?
Yeah, you would need to spin it up to get into it. One example I was going to do that just took way too long was starting with just a blank directory, and I was going to basically create a node container, throw some commands in it, hit a button, boom, it spins up a brand new Angular project within that container. So you can actually, as long as you define those container files, you don't even have to have any code right there. You can write your Docker file and go fetch stuff from your repo. So your local file system might never even see your actual code, but you're able to edit it in the container through Visual Studio.
And once you have the container up and running, you could read it up and run your code down in Visual Studio UI
Yes.
and come back to it later.
Yeah.
So,
Right now, the way it works, I believe there's a setting you can change in that file to leave it running when you shut, a setting you have to set to leave it running when you shut down. I think by default right now, as soon as you close that workspace, it winds down the container for you. But I believe there is a setting where you can say, I want to leave this guy going.
have you seen limits on like VSCode stuff on how many containers you can run?
I haven't. I've noticed, so Docker and the Mac have some issues in terms of the file sharing. I don't know if you're familiar at all with this, but there's the power of the Mac operating system caches files. Docker struggles with it a bit, so read-write speeds tend to be like cut in half unless you're really careful about how you set the volumes. Docker, it's in the repo, it's in the list of, hopefully in the next release that they were talking about having all those settings automatically done for you. You can do those manually. I just didn't want to go through all that. So the biggest bog down I see is because I've got a Mac, compiling stuff and doing some of that can feel a little bit slow. I'm working on a project right now. The first thing that I set up in this, and I went through and changed all my Docker files to the Mac way of mounting things, and it's much, much better than this. It just gets a little bit confusing.
So by mounting, I mean, you could mount your local drive into your container, or you could just use storage in the container.
Exactly. It's
Which
kind
one
of,
is first?
what's that?
Which one is this?
It's the mounting. It's the volume mounting, the host
Local
to
Mac
the.
policy.
Exactly. Exactly. It's pretty slow. And it has been for like 3 or 4 years. They haven't been able to fix it yet. So we've done these workarounds, but to do that, you have to define these volumes and put all these flags on it and stuff, and your Docker compose files end up really stretching out. So any other questions? Feel bad that I couldn't turn my buttons. That was my favorite part. It was like the finale, but sometimes it goes that way.
Thank you, Mark. I believe I don't actually have a JetBrains license for this month. And yeah, so I don't have a giveaway this month. Sorry, folks. But thanks very much for coming. If you want to stick around and chat for a little bit, you're welcome to. If you want to take home some pizza, they can't keep it all here. So I never can get exactly the right amount, but that's all right. Yeah, thanks very much for coming. What's up?
I'm trying to figure out, so running, like the things like this. I run expose on my machine. And I get what you're saying about the debug tools. I would tools either in command line or like I can get like Chrome debugger right for my front end, my UI. Are there more advanced debugging tools at the time?
In terms of running it in a container versus
versus not.
no, it's just that you can use the same set of tools whether you're running it in a container or not.
Okay.
So now when you're working with a group and they have everything containerized to keep the environment the same, you can literally just grab that container from the repo, attach the Visual Studio code in your Office.
Speed, I think the biggest difference is speed to get up and running and just pulling that versus like if you're all set on a repo and you're like having to get fetch and kind of like get up to date or get called and whatever.
The same bits that we're debugging are the same bits that we're going to debug. Exactly the same. There's no difference. You're using the same container to debug than you're going to use production. So there's no extra step or anything in between that's going to screw up your code. And that for me is a big deal.
You can literally take a container that you've been doing development and maybe you have a Docker compose file that imposes a bunch of restrictions on that container. You know, rather than running a production server, it runs the development server. And it exposes a different port because we're running it locally or something like that. But ultimately, the quote-unquote OS that's running in that container, oh, you're very welcome, I'm glad you enjoyed it, is identical to the OS that you're going to deploy. And I use OS in very loose terms. But essentially that environment stays the same between the two. So it doesn't quite allow you to develop in a production environment, but it allows you to develop in as close to a production environment as you can get. The only differences are whichever differences you personally impose.
Well, that's why I saw you split out the Docker Compose, like a dev, and then Docker Compose, typical YAML.
Exactly.
And there are differences both in port numbers and maybe packages.
Yeah, like in my dev package, I don't need my reverse proxy gateway, and I don't need my Let's Encrypt, because we're not actually serving up any actual URLs. We're just accessing them on different ports at local hosts.
Right.
Whereas for dev, I need my web server to know that it's app.domain.com and my API server to know it's api.domain.com, and they're both going to be served on port 80, and we're going to let this reverse proxy out front direct the traffic to. And so now, all you have to do is when you set up your developer Docker Compose file, you just drop off all of the infrastructure you don't need and keep what you need. And then maybe add some additional things that, like a web-based PHP min or something to help your development side, which wouldn't have anything to do with it. So it gives you this really broad flexibility, but the environment that each of these things is running in is very constrained, which is kind of a neat dichotomy.
We're going to show this thing. I think this is like, we go to send, we can change the color of the.
Oh, yes. And the reason why I didn't do that is because it didn't make
Yeah, exactly.
it didn't make my config file
DDR
for me.
Oh, that's interesting. That's where you get that.
Yeah,
To play DDR with your own task.
I was